Okay, so let us begin. Hi, everyone. Good afternoon to everyone. Thank you for coming. Um, Today's webinar is actually to talk a little bit about a project called EPICURE, which is extremely similar to what POP does. I usually say that it's a continuation of POP mostly. Um, so will be more or less our agenda for today. What is EPICURE? What is going on? What support services do we have? How to apply to it? Some of the success stories and some of the documentation that we have provided. And then at the end, we'll have a little bit of a Q&A so that you guys can ask me questions if you want to. Okay. So Epicure is a 4-year project. It started back in February 2024. It has 17 partners, which basically covers all departments, all partners involved, and all the EuroHPC machines. So all the major machines, Mare Nostrum, Lumi, Leonardo, all the petascale machines, including 84i, Carolina, Discover, ISM, the Calian in Portugal. So all the entities that are related to the EuroHPC supercomputing centers are connected to it, including ULISH. So what we do is basically provide application support teams in 2 levels, level 2 and level 3. I'll explain later what that is, but it basically covers everything from getting the best configuration and the best environment on your for your application to actually changing your code and optimizing your code so that you can scale up to large machines, especially now the pre-exascale and the exascale machines that are coming on board. Okay. And above all, it's a collaboration between all the centers in Europe and the centers of excellence, Okay. So, how can you apply to this project? Well, as long as you have an extreme scale, a regular access, a development access, or a benchmark access, you can apply to Epicure. There's actually a little box on the application form where you just say, I want ASD support. And you can that information will come to us when it's granted, and we'll start working with you on your project during the entire duration of the allocation. Okay. The 2 easiest ones to apply to is the development access and the benchmarking access. They are always open. Extreme scale and regular scale from EuroHPC opens twice a year. Okay. But as long as you have an allocation, we can help you out. Unfortunately, due to the nature of the project, we cannot support national users, but it's easy to get a development access or a benchmarking access project to actually start working with us. Okay. So what exactly do we do? Okay, we do code enabling and scaling, meaning if you have your application and your code, whatever it is, even if it's something that was not developed by you, I don't know, OpenFOAM or GrowMax, iPic3, doesn't really matter. If you want to run on these systems and you need help to actually use the software efficiently and help you scale correctly and get all the configuration and all the environment correctly to get benefits out of scale, then we can help you with that. We can also help you with benchmarking a little bit if you want to see how it behaves in scale and if it's really necessary to have that scale or not. We'll be able to do that with you. And then code refactoring and code optimization. So we actually can work with you on your code if the code is yours to actually change it, rewrite parts, either to target specific accelerators. All the machines across Europe have different GPUs, for instance. Lumi as AMDs, Jupyter as, of course, the super chips from NVIDIA. So we can help refactor your code so that it runs well on those and actually optimize for those particular platforms. And something that overlaps with POP, which is the performance analysis. So we can help you run your code and see where the bottlenecks are, where you can improve the performance of your code. How can you target new systems? So this is an overlap with POP and something that we collaborate often between us. It's not unusual for someone to start in POP with a performance analysis and then actually come to us to do code refactoring and code optimizations based on their recommendations. Okay. This means that we have two levels of support. One just for enabling scaling and help you go beyond the basic access to the machine, the basic setting up your accounting. So that's level one. That's something that we don't touch. But setting up your environment, making sure that your libraries are correct, that you're using the best libraries for each one of the systems. That all is handled under level two. And then level three support is code optimization. So we can actually work with you together where we become part of your team and we can actually help you to target large sales systems either by manipulating your code, optimizing it, making sure that it targets the right architectures, that it takes advantage of everything, that the communications are optimized, that we can help you port to GPUs and improve the scalability of the entire application to target really large systems when needed. Okay. So what don't we do? We don't handle things that can be handled by level one support. Things like general information about the system, login access, setting up your environment, whatever that is, preparing workflows or shop scripts. That are templates already and don't need too much change. And we don't handle software installation unless it's specifically related to your project, right? There's some situations where we will work with you to make sure that the software packages installed actually match your case, and we'll see some cases where simply by recompiling and linking different packages within the system, the performance was improved out of the get-go. Okay. Sorry. So how does this cycle works? Well, submit your proposal with the Access portal from EuroHPC. You will receive a confirmation email with a link saying that you have access to ASD. Just submit that form. It's simple to do. The project is accepted by us. Usually there's only one project that we said no because it was clearly a level one application, but everything else we did accept. And what we do during this project acceptance phase is actually to select the best team to help you. It's not that you are applying to a specific center. You are applying to a team that is distributed through all the centers. So we'll pick up experts from all the centers that can actually help you support your application and your target. Okay, and we'll collaborate until we achieve some kind of success that we'll define on a couple of meetings, and we'll have them on a regular basis to help you out and to help us out to give you support. Okay, so EPICURE by numbers. So we have more than 120 projects that we supported and that were successful, right? And by successful means that they actually got optimized efficiently. And we did also optimized codes. Some of them, they were part of CUEs because of specific things for specific machines. For instance, Lumi is a very, very touchy machine, and it requires a little bit of finesse to actually make things like Chromax and Quantum Express and PyTorch work efficiently. So we do support that. And we do support also AI and ML projects when needed for both industry and academia. Although we do support the execution, there's a sister project that you might have heard about called Minerva that actually does high-level support, meaning will help you choose the bundles, what would be the best ones for your targets. But to execute them, then you will come to us. So there's a lot of things that we did in the past. So some of examples, and I cannot, for privacy reasons, give you the total description of it. I would love to, but unfortunately no. But here's some of the areas where we have successfully helped users come into the system and execute their applications. And Catalyst Reaction, it's one of the best where we actually changed the libraries that were supporting Python, like the BLAS library, some of the eigenvalues libraries, some of the IO libraries that were underneath Python, because Python brings everything that is generic. It doesn't bring the binaries for that specific machine and optimized for that machine. It's optimized for a generic machine. So by us efficiently linking those libraries and putting them in place for the user, they were actually able to get about 20% of performance improvement, right? And this is without changing a single line of code. It's just changing the environment that you are working with. And that's what the ASTs are here for. And we also worked a little bit on environment. Sometimes in real life, speed ups are not that big. 7% of speed up is not that big. On your local machine, 7% might be extremely small. If you're talking 7% on a machine like Jupyter, where you're using thousands of nodes for computation, is actually quite a good number, despite the fact that it's low. It represents a lot of nodes, and it represents a lot of energy at the end, right? And we also so these are model-based physics, and we also worked with AI where we help the users to set up their training, to set up the scale of their training, how they actually run. Sorry, how they actually run their system, and we were able to help them reduce the training time of their data set. Here's some more concrete examples of it that we are kind of allowed to work with. A large-scale fission for properties and energy densities. They come to us with the objective of benchmarking with Scalapack, invest a little bit on replacing a library that they had called Alpa, refactor the Fortran code. It was extremely old, and we needed to get it more to a more recent version, and then integrate a little bit of ML into their pipeline, right? What we ended up doing with them is making sure that they had the PyScalapack, the latest version, running and suitable for Lumi, making sure that their Alpa was also there, and then try to create a backend for them that would make it agnostic to either if they were using Scalapack or Alpa. One of them without having to do a lot of code changes, right? And we did a lot of extensive system benchmarking, right? There's a little bit of a mistake here, but well, one of the things that we did was actually help was um, faster than Scalaback, which is actually a good thing, because it was something that they were wanting to do, and they were able to get 2 to 5 times faster on small systems. So we're talking about petascale size, but on the pre-exascale that were available at the time, they were actually able to scale up to really large number of nodes and get 10 to 20% faster for these large systems, right? Um, and we were able to convert their entire code to more than Fortran, which is something that people have a tendency to not want to update their code and leave it on the version of the language that they were born. In this case, if I recall correctly, it was Fortran 80, which is extremely hard to work with, and even if we want to get performance out of it, it's extremely hard to do. So we were able to modernize the Fortran and interlink it with Python module approach in a more efficient way than they were doing previously. Okay. Couple of things that I want to tell you. We do have a portal available. We always are updating that portal as much as we can. We are always placing how-to guides as what is the best way to compile, what is the best way to run, what are the best scripts. If you are doing ML, what is the best way to set up your ML pipeline and workflow for each one of the systems, so everything goes in there. These how-to guides will give you a head start in relation to other things. We also do best practice documentation, meaning recommend workflows, compiler flags, MPI settings, configurations for almost, we are trying to cover a lot of the HPC applications out there, but some of them are generic that will work even on your own codes. And sometimes we do leave code snippets to alert users for specific problems or specific improvements that they can do for specific machines, or more generic ones that they can target other systems, right? And the online training material that we do is also there. All the content of lectures, workshop slides, and everything is placed there. Okay. And the reason why we do this is because sometimes we think that we understand how things work, but the reality is slightly different than what we think, right? This is an example of a project that we were working with that was generating and applying stencils to the application on Lumi, but it was slower than anything else that they've ever seen. They could not really understand why that was happening. And when the specialist took it, the specialist from EPICURE took it, he actually saw that it was made with the assumption that the distribution for NUMA and the distribution for the GPUs were exactly the same and they were symmetric and so forth, which is not the case exactly for the Lumi the Lumi nodes, right? There is a specific configuration that needs to be done and needs to be tuned in terms of topology so that it actually takes advantage of the node itself. So the objective was to make sure that it would compile and port correctly and scale within these issues inside the Lumi GPU. We did that. We did optimizations on the code, especially across the way that the memory was allocated on the NUMA controllers so that the system could actually take advantage of all the buses and all the links available on the node so that they could get performance out of it. And at the end, the performance was uh, extremely better, and they achieved at least 10 times the speed up that they were getting without making these changes. Okay. And there's some situations where we work with COE specifically to make sure that their workflows are well designed for each one of their of the targeted systems. So some of the Lighthouse codes and some of the Lighthouse COEs, they have really good experts on board in-house. They really know what they're doing, and they can really target some of the architectures extremely efficiently. But in the end, getting the software on the machine, making sure that each one of the recipes and the libraries and dependencies are correct for a particular machine, and they need to make sure that it's installed and running on all the machines. It's not an easy task for them. Most of the time, something that works in one will not work efficiently on another, either because the OS is different, the architecture is different, the network is different, whatever is happening there is different. And in this particular case, that was a problem. They are using two softwares. One is a variation of WRF S-Fire to calculate fires. And what they needed was to help out set up the easy build recipes and develop those recipes and make sure that the software was compiled correctly within the recipes for each one of the systems. They could be deployed automatically for each one of the targeted machines. Okay. And the same thing happens with machine learning. Sometimes we think that machine learning, we just use whatever comes with PyTorch. It will work great. It will do everything that we want to do. But that's not the case. Most of the users that we've seen with AI, except for the big players that have been playing with AI for a really long time, but especially new people coming in, they see AI just as a single GPU, and they have difficulty scaling and setting up the scaling for the type of machines that we are using and targeting for these clusters. So we work with them to find the best distributions, to find the best way of representing data and finding the best way to get bandwidth out of the system and to make sure that that it gets the most performance out of the system and that they can use really, really well their allocation. Okay. So how do we interact with POP? Usually the user goes to POP to request a performance assessment. That's what they're good at, and that's their specialty. And they really do an awesome work on that sense. But at the end, they just identify the problems, scaling, the architecture gaps, optimization needs. All of that comes out on a report. In some cases, they will retouch one or two things if it's a small process. But in the end, usually it's always the identification of the problems on the system, and then the user needs to work by themselves. And that's where EPICURE comes in. We can give you the expertise, the CS expertise to actually get those results and get that scaling and actually help you to modify your code so that you can use these machines efficiently and target the machines in a large scale. Okay. And having said that, thank you so much. Open for questions that you have, comments that you want to make.
Yeah, thank you so much for this nice overview. Um, yeah, being from pop, let me jump in on your quickly on your last slide. There's one additional thing, of course. Pop free does assessments anywhere in Europe for anyone. You don't have to have a EuroHPC allocation. So we can also, yeah, if you're a small SME or with your own local system, a company or a university or whatever, we also are allowed basically to give you service while EPICURE is, of course, targeting EuroHPC systems. Piero, you want to have a question?
Yes, sorry,
Please go ahead.
I want to raise my hand. No, very simple. Very interesting. I do not fully understand the relationship with the central excellence activity, no, because it looks like in some case, you may have some overlap, in the activities that are more or less similar, no, in some case. So how to manage this? But
So,
yeah,
your question is, how do we manage the overlap between Epicure and Pop? Usually, we don't manage, unfortunately. The reason why is, well, we also have expertise in profiling and accessing and so forth and all of that. We don't go as deep as Pop. So if there's something that kind of escape us, we have a good relationship with Pop, and some of our team members are also part of Pop. So we just throw the project over the fence and say, "Hey guys, talk to Pop so that they can help you out."
yeah, but not. Yeah, sorry, maybe it was not so clear. So not only POP, also other COE activity. So for example, cheese. I representing also cheese community in so solid earth or meteo climate. So
Mhm.
easy ways and so on.
That
So not only POP.
is, yeah. So when we're talking about COEs, it depends a lot on the request that is done. So usually we have a meeting on the first thing that we do when we receive something is we'll have a meeting and we'll talk about it. And one of the things that we cannot do, that we are completely forbidden from our side, and the other COEs are also forbidden, is the overlap of missions because of double funding. So I can say, for instance, one that I know really well, Hidalgo too. Hidalgo has come to us and say we don't have expertise on getting these recipes done. We need them, right? And we said okay. And one of the other things they said is we're having problems optimizing this code on for this particular platform and blah. So we did basically what Pop does. We gave him a consultation, say, be careful with this and be careful with that. But we cannot touch your code. Right? We kind of may act as a consultant, say, be careful with this part or be careful with that part, but we cannot touch your code, right? There is one specific COE that doesn't have any code development at all on their mission. And in that case, we can just go in and change the code. So we need to make sure that your mission and your grant agreement and our grant agreement don't overlap because we cannot go into double funding and find a way of playing with that. And seeing exactly how that works, right?
Okay, thanks.
But it seems to be a little bit specific to the different COEs, how they think about this issue.
Yeah.
Some COEs think more, yeah, because another thing what EuroHPC is asking is collaboration between the projects and between the COEs. So when they basically say, okay, this is a way to do a successful collaboration with another COE, they let do things. Or as I said, if we are more concerned about double funding, or especially if they have a COE has their own work package on optimization or something, then typically there's more concerns about double
Yeah.
funding and this kind of thing. Yeah, we see it in both ways from pop side.
Yeah. Both sides work that
Yeah,
way.
yeah.
There is a third option, right? Where, and it has happened in the past. The answer unfortunately came back now, which is we were not entirely sure they really needed the help. We really had the expertise, so we actually set it up to our HPC and asked, "Look, this is a situation." We completely explained what was going on. Unfortunately, their answer came back as no. Unfortunately, the reason why I don't know. It's not my preview, but that's something that sometimes could happen and could be done.
Okay. Thank you. Any other questions of the people in the list? It doesn't look like that. Yeah, so I think, yeah, why not have a shorter webinar from time to time? So thanks again, Joe, for this interesting presentation about EPICURE. And now, yeah, people will have a choice to go either, yeah, especially if they have a Euro HPC system allocation, they can do both, or pick one or the other, or do one of the procedures that you explained. So thanks again. Thanks everyone for joining, and see you soon in the next webinar, which will be early June. Thank you.
Okay, everyone. Thank you so much.